You've seen the sun rise thousands of times. You've watched it set. You've squinted at it through clouds and felt it on your face on a cold morning. You've never seen the sun. What you've seen is light that left the sun 8 minutes and 20 seconds ago. The sun you're looking at right now is not the sun as it is. It's the sun as it was. By the time those photons reach your eyes, the surface they're showing you is already ancient history by the sun's standards. This isn't poetry. It's physics, and it applies to everything you've ever seen. Here's the fundamental problem with seeing the present. Seeing requires light. Light takes time to travel. Those two facts together make it physically impossible to see anything as it currently is. When you look across a room, the delay is tiny, a few nanoseconds. The far wall is a few nanoseconds in your past. That's so small it's irrelevant for any practical purpose, but it's not zero. It's never zero. When you look in a mirror, you're seeing yourself as you were a fraction of a nanosecond ago. When you look at the moon, you're seeing it as it was 1.3 seconds ago. When you look at the sun, 8 minutes and 20 seconds. When you look at the nearest star beyond the sun about 4 years ago, the present is structurally inaccessible to vision, not because our instruments aren't good enough, not because we haven't figured out the right technology, because of what seeing fundamentally is. You can only ever see where things were, never where they are. The universe does not allow real-time visual observation of anything, not of distant objects, not of nearby ones, not even of the thing directly in front of you. Let's make the 8 minutes concrete. Light travels at 299,792,458 meters per second. That is the fastest anything can move in the universe, not a speed limit that might be broken with better engineering, a fundamental feature of how space and time work. The sun is approximately 150 million kilometers away. Divide that distance by that speed and you get 499 seconds, 8 minutes and 20 seconds. Now, here's the thought experiment that makes the delay feel real. Suppose the sun disappeared right now, just ceased to exist, instantaneously gone. For the next 8 minutes and 20 seconds, you would have no idea. You would feel the warmth on your skin. You would see the light coming through your window. You would go about your morning completely normally, and the sun would already be gone. Only after 8 minutes and 20 seconds would the last photon that left the sun arrive at Earth. After that, nothing. Darkness, cold, no warning, no signal traveling faster than light to tell you what happened. That's not a thought experiment designed to be disturbing. It's a precise description of how information actually works in a universe where nothing travels faster than light. Think about what that photon went through to get to you. It's generated at the sun's surface, in the violent convective zone where plasma boils and churns at thousands of degrees. It launches itself outward at the speed of light, the fastest possible, 299,792,458 meters per second. Ahead of it, 150 million kilometers of vacuum, not thin air. Vacuum, almost nothing. The occasional hydrogen atom, sparse dust, the solar wind of charged particles, but essentially empty space between here and there. The photon crosses that in 8 minutes and 20 seconds. Then it hits Earth's atmosphere, scatters slightly off air molecules, passes through, maybe through your window, across your room. It hits your retina. A single photoreceptor absorbs it. The absorption triggers a chemical cascade. That cascade triggers an electrical signal. That signal travels to your visual cortex. And somewhere in that process, you see the whole journey, 150 million kilometers plus the width of your room, took 8 minutes and 20 seconds. And the information that photon carried was fixed at the moment it left the sun's surface. What it showed you was the sun at the moment of departure, not at the moment of arrival. You received news from 8 minutes ago, delivered with perfect accuracy, but 8 minutes old. Now here's where it gets genuinely strange. Those photons that left the sun's surface 8 minutes ago and showed you the sun's exterior, those weren't new photons. They were old. Very old. The photons that ultimately reach you were generated at the sun's core. That's where nuclear fusion happens. Hydrogen fusing into helium, releasing energy in the form of photons. That's the energy source. That's where the light starts. But the core of the sun is not empty space. It's plasma at 15 million degrees and a density about 150 times that of water. When a photon is created in the core, it doesn't travel to the surface in 8 minutes. It immediately gets absorbed by nearby plasma. The plasma re-emits a photon, which gets absorbed almost immediately again, then re-emitted, then absorbed. This process, photon created, absorbed, re-emitted, absorbed, re-emitted, on and on in a random walk through incredibly dense plasma, takes somewhere between 10,000 and 100,000 years for a photon to make its way from the core to the surface. Once it reaches the surface, then it travels to you in 8 minutes. The light hitting your skin right now was created in the sun's core before modern humans existed, before our species built the first tools. The energy was trapped in the sun's interior for 100,000 years, bouncing around in a random walk before finally escaping to the surface and then spending 8 minutes getting to your face. You're being warmed by ancient energy, energy that was imprisoned inside the sun for longer than Homo sapiens has been a species. The sun is 8 minutes away. Now look up at the night sky. Every star you can see is at a different distance, which means you're seeing each one at a different moment in its past. The night sky is not a photograph of the universe as it currently is. It's a collage of different historical moments, all displayed simultaneously. The North Star, Polaris, is approximately 434 light years away. The light you see when you look at it left in the 1590s. You're seeing the North Star as it was when Shakespeare was writing his plays. Whatever is happening there right now, you won't know for 434 years. Betelgeuse, the distinctive red star in Orion, is approximately 700 light years away. You're seeing it as it appeared around 1325, before the Black Death swept through Europe. Whatever Betelgeuse looks like right now, that information won't arrive for 700 years. Andromeda, the galaxy you can faintly see with the naked eye on a dark night, is 2.5 million light years away. You're looking at it as it was 2.5 million years ago, when our ancestors were early hominids. Some of the stars you can see tonight may not exist anymore. They could have exploded centuries ago. The light of that explosion is traveling toward us right now, still in transit, won't arrive for generations. We're watching a star that's already gone and we have no idea. Betelgeuse is worth pausing on. It's a red supergiant, one of the largest stars visible from Earth. If it replaced the sun in our solar system, it would extend past the orbit of Jupiter. It's at a late stage of its life, and astronomers expect it to eventually go supernova, the violent explosive death of a massive star. When that happens, it will be extraordinary. For a brief period, it will be visible during daylight. At night, it will cast shadows. It will be the most spectacular astronomical event humans have ever seen. The question is when, and the answer is we don't know. But it might have already happened. If Betelgeuse exploded 500 years ago, the light from that explosion is currently traveling toward us. It will arrive in approximately 200 years. There's nothing we could do with that information if we somehow had it. We just wait. The star you see when you look at Orion's shoulder might be the ghost of something that ended centuries ago. An image preserved in light, still traveling, arriving like a letter from someone who has long since died. This is not philosophical. It's a straightforward consequence of information traveling at a finite speed across vast distances. Zoom out further. The universe is approximately 13.8 billion years old. The furthest light we can detect comes from approximately 13.8 billion years ago. It's the cosmic microwave background, the afterglow of the early universe. Light that has been traveling since the universe was only about 380,000 years old. That's the oldest light in the universe. We can detect it. We've mapped it. We can see structure in it that tells us about conditions in the very early universe. Beyond that, there's no light to see. Not because nothing exists, because the universe wasn't old enough for light to have traveled to us yet. In the early moments of the universe, matter was so hot and dense that it was opaque. Light couldn't travel freely. The cosmic microwave background represents the moment the universe cooled enough to become transparent, and light could finally travel freely for the first time. Before that moment, we're blind, not because nothing happened, because no light from that time could reach us. The edge of the observable universe is literally the edge of the past we have access to. A horizon defined not by distance alone, but by how long the universe has existed and how fast light can travel. And there is almost certainly more universe beyond that horizon, much more, possibly infinite more. We just can't see it. Its light hasn't arrived yet. This is what telescopes are actually doing. When astronomers point a telescope at a distant galaxy, they're not viewing the present state of that galaxy. They're viewing the past state. The further away, the further in the past. A galaxy 5 billion light years away is being observed as it was 5 billion years ago when the universe was roughly 2/3 of its current age. The Hubble Deep Field image, one of the most famous astronomical photographs ever taken, pointed Hubble at an essentially empty patch of sky for days. The accumulated light revealed thousands of galaxies, some of them as they were over 13 billion years ago, when the universe was less than 1 billion years old. Not simulations of what they looked like, not reconstructions from models, actual light from those actual galaxies. Photons that left their source over 13 billion years ago, that have been traveling since before Earth existed, that finally ended their journey on Hubble's detector. The James Webb Space Telescope is designed to push further, to see the first galaxies that ever formed, light that has been traveling for over 13 billion years. Cosmologists studying the early universe are not theorizing about what happened. They're looking directly at it. The past, for them, is not an inference. It's an observation. The further you look, the earlier in history you see. Astronomy and paleontology are the same discipline in this sense. Both are reading the record of the past. One reads rocks, the other reads light. The reason you can't see the present sun is the same reason we can never know what's happening right now anywhere else in the universe. There is no mechanism for faster-than-light communication, not a technological limitation we might overcome, a physical impossibility built into the structure of space-time. Right now, on a star 1,000 light years away, is not something you can access, not with any technology, not with any physics, because special relativity shows that simultaneity itself is relative. There is no absolute right now that applies across the universe. What is simultaneous for one observer is not simultaneous for another moving at a different velocity. The very concept of what's happening right now somewhere else is not a well-defined question. The information delay isn't a bug in our observational tools. It's a feature of how space and time are structured. The universe has a speed limit. That speed limit creates a horizon of information, and we live behind that horizon, receiving news from the past, unable to know the present state of anything beyond our immediate vicinity, and then add the neural delay. You don't even experience the past delivered at the speed of light directly. Your brain adds its own delay. From the moment light hits your retina, to the moment you consciously perceive an image is approximately 80 milliseconds. The brain integrates signals from multiple senses, cross-checks them, constructs a unified experience, and presents it to consciousness. The experience of the present you're having right now is a reconstruction assembled from signals that all took time to arrive, processed by a system that adds its own processing time, labeled by your brain as now. The sun you're experiencing right now left its surface 8 minutes and 20 seconds ago, traveled 150 million kilometers, entered your eye, triggered a neural cascade, and arrived in your consciousness 80 milliseconds after hitting your retina. And before those photons left the sun's surface, they spent 100,000 years bouncing around inside the sun's core. So the light warming your face right now is delivering information that is, depending on how you count it, somewhere between 8 minutes old and 100,000 years old. Now is not a moment you have access to. It's a label your brain applies to a recent reconstruction of a signal from the past. Feynman would say the universe doesn't owe you real-time information. You get what the physics allows, and what the physics allows is the past, delivered at the speed of light, processed by neurons, labeled as now. Every star in the sky, every face you've ever seen, every sunrise, everything you've ever looked at, all of it past, all of it delivered to you as a record of how things were, not how they are. You have never seen the present. Nobody has. Nobody can. What you've seen is an extraordinarily detailed, beautifully accurate record of moments that have already passed. That's not a limitation to be sad about. That's the universe telling you something true about itself. It has a speed limit, and you live inside it.